Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra class. Today we are going to continue talking about polynomials and how to factor them. And today we're actually going to learn about a very important skill, which is factoring by GCF and grouping. Real quick, everything we learn, I'm going to just summarize for us right now. In order to understand factoring monomials from polynomials, you must remember what a factor is. Please remember that a factor is any real number, or monomial for that matter, that goes into another real number evenly, or another real monomial evenly, without a remainder. For example, the factors of 20 are 1, 2, 4, 5, 10, and 20, because all of those numbers divide into 20 evenly without a remainder. The GCF, or the greatest common factor, is the largest common factor between two or more terms, or numbers, or monomials. For example, the GCF of 40 and 70 is 10, because that is the largest common factor that they share. 10 is also divisible into 70 and 40 evenly without a remainder. So how does this apply to polynomials? In essence, my friends, when you're factoring a polynomial, okay, it's kind of like you're reversing multiplication. You're reversing, actually, the distributive property. Remember how the distributive property, you multiply everything, the outside value to everything inside? Well, when you're factoring a monomial out of a polynomial, you're dividing the GCF from every term and then placing it outside. So when you are factoring a polynomial, simply find the GCF, if any. Sometimes you don't have any. And factor out that GCF by dividing the GCF to every single term of the polynomial and placing the GCF outside of the parentheses. It is the reverse of the distributive property. So you find the GCF and you divide the GCF to every single term. And you put the GCF outside of the parentheses. It's the reverse of the distributive property. Please remember that the GCF of like variables always belongs to the variable with the lowest exponent. So for example, the GCF of x to the 8th, y to the 5th, z to the 6th, and x to the 6th, y to the 3rd, z to the 8th would be, guys, would be x to the 6th, y to the 3rd, and z to the 6th. Phenomenal. Thank you. So let's get to it, because we got a lot to do today. So for number 1, I've got negative 15x to the 6th minus 3x to the 4th. What is the greatest common factor to this? No. How could it be 5, guys? No, how could it be negative 5? 5 is not a factor of 3. Negative 3, what else, guys? Very good. So I've got negative 3x to the 4th. That's on the outside. What's on the inside? The leftovers. I divide the GCF to every single term. What is negative 15x to the 6th divided by negative 3x to the 4th? 5x squared. Beautiful. What's negative 3x to the 4th divided by negative 3x to the 4th? Positive 1. Fantastic. You're done. You just factored a polynomial. You found the GCF. You divided that bad boy from every single term, and you place it on the outside of the parentheses. Does that make sense? Okay, next, number 2. What is the GCF of 4x squared minus 3x? X. I put that outside of the parentheses. Now I have my leftovers. Divide x to everything. What am I left with? 4x minus 3. Not cubed. I don't know where you got cubed from. Remember, when you're dividing variables, my brother, you keep the base and subtract the exponents. So if there's an x here, you get rid of one of x here, one of the x's here. So you're left with 1x. Here, x divided by x, it cancels. Anything divided by itself equals 1. Number 3, what is the GCF here, brothers? 4y cubed. Fantastic. Now divide that to every single term. And that's what your leftover is. So what are my leftovers here? Y cubed minus 7y to the 6. Beautiful. Plus 4. Fantastic. Excellent. Excellent. Good job. Number 4. What's my LCD there? I'm sorry. What is that? What is my GCF there? Sorry. 5x cubed. Fantastic. Put that in parentheses. Divide that GCF to every single term. What am I left with? 2x squared plus 4x. Good. Minus 3. Fantastic. Wow. You guys are awesome. Good job. Really good job. Now, you know I always got to throw in a word problem here and there just to keep things spicy. So today, I want to give you a very, very basic but important SAT type question. This is huge on the SAT. They love doing these. I'm going to show you right now today how to tackle these, and you're never going to have to worry about it again. Find the area of the shaded region. Guys, what are the two shapes I have here? Very good. I have a square, and then I have a circle. What do you think I do logically? How, in order to find the shaded area, what do you think I would do? No, finding the GCF for those two isn't going to work, but you're thinking, thank you. Find the area of the whole entire square, and then find the area of the circle and subtract it. Beautiful. So let's do it. All right. The area of the square is side squared. What is the side of this square that they gave you, my brothers? So this area equals 4x squared, which equals 16x squared. Be careful, guys. It's not 4 times 2. It's 4 squared. So it's 16x squared. Phenomenal. Phenomenal. Okay. My area of a circle equals pi r squared, where r is the radius. What is the radius for this circle, my friends? Very good. So this is going to be pi times 2x squared. So that's going to equal 4x squared pi. Is everyone with me so far? Now, you guys told me, I didn't tell you. You told me. You said, Moro, now take the whole entire area and subtract it from the circle area. Right? That's what you guys told me? Now, I can simplify this by factoring. What can I factor out of both of these? What's the common factor? What's the GCF here? Why would you say negative if there's only one negative? I'm not mad, I'm just asking. Think about that. If they're both negative, then you factor out a negative. Thank you. So 4 is part of it. 4x squared. Now, what are my leftovers, my brothers? 4 minus y. Why a y? Where's the y? 1 pi. No, thank you. You're human. And that's units squared, because area is always units squared. Does that make sense? That's factoring out a GCF. That's the first part of today. Mickey Mouse time, right? Pretty simple, right, y'all? Awesome. Next thing is pretty simple, too. Sometimes, my friends, you're going to be given polynomials that have a common binomial. That's a 2-term polynomial. And I'm going to abbreviate, just for time's sake, common binomial with CB. So factoring out a common binomial works the same as factoring out a GCF, I promise. Same concept. When you're factoring any polynomial, simply find the CB, the common binomial, if any. Then factor out that CB, that common binomial, by dividing, just like the GCF, the common binomial to every single term of the polynomial and placing the common binomial outside of the parentheses, just like so. It's exactly the same as a GCF, except you're not going to be factoring out a GCF in this particular case. You're going to be factoring out a binomial. So if you look at A, my friends, I got 8 times x minus 3 minus 3x times x minus 3. What's the common binomial of these two terms? Guys, look at this. Look, this is one term. This is another term. What are the common binomials here? Very good. So pull out an x minus 3. Now remember, divide the x minus 3 to every single term. So what am I left with? What are my leftovers? No. What's x minus 3 divided by x minus 3? No, it's 1. They cancel. So I'm left with 8. And then here, minus 3x. Done. Does that make sense? Remember, guys, just like any number divided by itself equals 1, any polynomial divided by itself equals 1 as well. So when I have x minus 8 minus 3x, I'm sorry, x minus 3 divided by x minus 3, that equals 1. They cancel. How about for B? What's the common binomial here? Okay, y3 doesn't exist, my friends. Good. Y cubed plus 6 is my common binomial. What are my leftovers? When I divide that by y cubed plus 6 and that by y cubed plus 6. What are my leftovers? Negative y plus 1. Fantastic. Great. Great. C. What's the common binomial here? Yeah, be careful. You see how the x squared is over here at the end? But this is still a negative 5, right? So these are both equal. Very good. So I got x squared minus 5. And what are my leftovers? My leftovers are 2x minus 3. Fantastic. Fantastic. D. What are my common binomials here? Thank you, sir. Phenomenal. W plus 2. W plus 2. W plus 2. 6w plus 7. Fantastic. Done. Phenomenal. Phenomenal. Very proud of you. So far, so good, my brothers? I hope everyone out there in the internet world is also understanding this. Okay. Now let's put the two skills together. Sometimes you have to factor what's called a 4-term polynomial. Whenever you have a 4-term polynomial, think of grouping. Think of this method. It's not going to work with 2 terms or trinomial or 20 terms. It's going to work with 4 terms. Okay? And it is very easy if you apply what we just learned. The goal is to create, listen, the goal is to create 2 identical binomials, 2 common binomials from the given 4-term polynomial, which are then grouped together and factored out. Here's how it works. I want to factor 3n cubed minus 12n squared plus 2n minus 8. Okay? This is 4 terms. So the way I'm going to factor this by grouping is as follows. Group the first 2 terms and the last 2 terms, forming 2 binomials using parentheses. So what am I talking about? Literally. Put a parenthesis around here. That's one binomial that I created. Then you put a little plus sign, and you put the second set of parentheses. Please notice the sign of this, whether it's positive or negative, stays within the parentheses. So to make it really pretty, that's what it should look like. You put the parentheses around the 3n cubed and the 12n squared. Put a little plus sign. Parentheses around the positive 2n minus 8. So,
Does it really matter if you put 2 plus?
Yes, it matters huge. Because if this is negative and you put it on the outside, you're going to get it wrong. So like I said, it is extremely important to keep this sign. Step 2. Here's, yes, sir. Yes, sir. Well, the polynomial has to be in standard form, not necessarily. Not necessarily. You could rewrite it in standard form. Sometimes you have to rewrite it in standard form to make it work. But yeah. Thank you. Step 2, factor out the GCF of each binomial that you just created, which leaves you with 2 identical binomials. So here, what can I factor out of this bad boy? A 3n squared. And what are my leftovers? N minus 4. What can I factor out of this bad boy? Positive 2. And what am I left over with? N minus 4. See what I just did there? Guys? See what I just did there? Okay. I factor out a 3n cubed squared. Here's my leftover. Factor out a 2. Here's my leftover. Don't I have now 2 common binomials? Guys? So now, factor the common binomial as its own. Factor out the common binomial and group the GCFs as its own binomial. I factor out an n minus 4. And what are the leftovers? 3n squared plus 2. Very excellent. Bada bing, bada boom. Does that make sense? My friends? Okay. Very good, very good. Very good. All right, now, let's practice. Okay? Factor out each polynomial. All right, I've got 4 terms. So watch me, guys. Follow directions. First, make 2 binomials. Then, factor out the GCF. From here, it's going to be a 3x squared. So I have a 3x squared. My leftovers here are going to be 4x minus 3. From here, I'm going to factor out a 5. So I factor out a 5, and my leftovers are 4x minus 3. See now how I have 2 identical common binomials? Now use the skill we just learned. 4x minus 3 times the leftovers of 3x squared plus 5. Does that make sense, my friends? It's not that bad, is it? Talk to me, sir.
No, I just got it.
You got it, my man? Thank you, my brother. Okay. Here, for B, make 2 binomials. Factor out each binomial. So I got 7x, and the leftovers here are 2x squared minus 1. And here, factor out a 7x. What is wrong with me? Sorry. Factor out a 4x in this case. And I've got 2x squared minus 1. Now I have 2 common binomials. Factor out the common binomials. Leftovers, 7x plus 4x. But hey, wait a second. I can combine those. So that will become, what's 4x's plus 7x's? 11x. You guys with me here? Hello? Okay. Does that make sense, guys? Promise? Okay. Very, very good. Okay. Now, what happens when you have a reversal of a binomial by a -1? Note, remember the power of -1. If you have the following two binomials, you got x minus 2 and 2 minus x. Are those guys equal binomials? Are those common binomials? No. I'd have to make this 2 a negative and this x a positive, right? What do you think I can factor out of that to make that happen? A -1. If I have 2 minus x and I factor out a -1, it's going to give me -1 times x minus 2. Now I would have my common binomial. So if you have common binomials, but they're differing by one negative, you can factor out a negative value and it will switch the signs. Okay? What am I talking about? I have 3x cubed minus 15x squared plus 10 minus 2x. So I'm going to separate them. Good job. Thank you, my brother. I'm going to factor out a 3x squared here. So I got 3x squared. My leftovers are x minus 5. Now here, if I factor out a 2, check out what happens. I'm left with 5 minus x. Is that what I want? So instead of factoring out a 2, what do you think I should factor out? A -2. Genius, guys. Genius. Good job. Now this will become a -5 plus x. Now are they the same?
Yes.
Yes. So now I factor out my x minus 5 times the leftovers of 3x squared minus 2. Does that make sense?
Yes.
Promise.
Yes.
Okay. Next, go ahead and group them. Two binomials. Factor out the GCF. In this case, it would be 5x squared. So I'd have 5x squared times my leftover of 3 minus 2x. Then from here, I can factor out a 4. But wait a second. When I have a 4 there, look at what happens. I get 2x minus 3. That's no good. So what do I have to factor out instead of a 4? Beautiful, guys. I'm so proud of you. So proud of you. So proud of you. Factor out a -4. So now I have -2x plus 3. Now are these binomials the same? Heck yeah. Factor them out, my brothers. Yeah, no, you're right. You have the -2x plus 3 and then your leftovers, 5x squared minus 4. You said it perfectly. You said it perfectly, son. Good job. Okay? Now, I'm very proud of you guys. We got one last, let's put it all together. Nothing new to learn. Okay, I promise you. You have my word on that. But it's just a matter of now let's put it all together. So far, my friends, you have learned very, very important stuff. You have learned that whenever you're given a polynomial, the first thing you want to do always is factor out the GCF or a common binomial if it's possible. Number 2, if you are given a 4-term polynomial, factor that bad boy by grouping. Fair enough, right? All right. So let me show you what I'm talking about. I got 4x cubed minus 10x cubed. Let me start that over. I have 4q to the 4th minus 10q cubed plus 16q squared minus 40q. What's the first thing I said you always got to do? No. Always first check to see if you have a GCF, guys. Before you do grouping, or any of the other factoring methods that we're going to learn soon, always factor out a GCF if possible. Do I have a GCF here that I can factor out? 2Q. So now I'm left with, come on, Moro. Learn how to multiply. 2Q cubed minus 5Q squared plus 8Q minus 20. Does everyone see that? So all I did was factored out the GCF first. Now, am I not left with a 4-term polynomial? How do we factor 4-term polynomials? How do we factor 4-term polynomials? Grouping. So now, group it. Group it. Do not forget this 2Q. That 2Q follows you always. So put a bracket. What can I factor out of this bad boy now? A Q squared. So I have Q squared times 2Q minus 5. What can I factor out of here? Good, a 4. So I factor out a 4, and I'm left with a 2Q minus 5. Guys, am I doing anything different than what we've just done? No, right? Now, I have my common binomials. So now, this is how you would write this answer. The GCF that you pulled out from the beginning times the common binomial that you can pull out times the leftovers. And bam, you're done. Does that make sense, my brothers? Okay, number 2, thank you. God bless you guys. You're awesome. Okay, number 2, can I factor anything, any GCF from every term here? No. So, no GCF. What's my next step? I got 4 terms. Heck yeah. Group them. Thank you. Awesome. Notice here how the negative stays inside. So here I can factor out a 2r squared. So give me 2r squared. And I have a leftover of r plus 6. What do I have to factor out of here to be left with a positive r plus 6? Thank you, gentlemen. Negative 5. So I got r plus 6. Now, do I have 2 common binomials? Factor that bad boy out. I'm left with my leftovers of 2r squared minus 5. Thank you. Excellent. Excellent. For number 3, can I factor something out of every single term here? Yes, you can. If you remember the divisibility test, 4 goes into all of these. Actually, no, 8 does not, because 28 and 8, no. But 4 does. So I'm going to pull out my 4. That's my GCF. Left with 2p cubed plus 7p minus 8p squared minus, that's 23. Is everyone with me here? No, that's wrong. That's wrong, Mr. Morrow. That is very wrong. 2, that's it. That's an 8, no, 28, sorry. Sorry. Had a little confusion there. Okay, now, I factored out my GCF. I got 4 terms, though. So now let's group them. Bring down that GCF always. Now I factor out a p, so I got p times 2p squared plus 7. From here I can factor out a, not a 4, but a, no, negative 4. Good job, guys. I'm left with 2p squared plus 7. Now I have my 2 perfect common binomials, right? Yeah. So now the GCF times the common binomial times the leftovers. Does that make sense, guys?
Yes, we do.
And that's squared. Okay, does that make sense, guys? Okay, now I got 8x cubed minus 64x squared plus x minus 8. Group them. Okay. Oh, wait, my bad. My bad, my bad, my bad. Wrong question. The first question, is there a GCF? No. Ah, that's a good trick, right? Got you guys, good. So no, there is no GCF. So now we group. From here I can factor out an 8x squared, leaving me with x minus 8. Okay, now, moral, that is an x minus 8. So what can I factor out of there to keep it as an x minus 8? I got to factor something out. Factor out a 1. Great job, guys. Great job. So now I got my x minus 8, my common binomial, times my leftovers of 8x squared plus 1. And my friends, you have just learned the first 2 steps of factoring polynomials. Thank you very much. Hope you learned a lot, and have a great day.